Okay guys, so last class we started doing the graphs of exponential functions, and on the drill you saw what's expected of you. Without a calculator, you're going to need to know if it's growth or decay, what shifts there are, things like that. The rest of today we're going to look at what about exponential growth and decay models. So word problems, equations to represent them. So obviously we know words that can mean growth or words that can mean decay, increase, right, decrease. Even in terms of money, the word appreciate means increasing, and then even for decay, depreciate is a popular one. If something depreciates in value. So basically, look for these context clues about which one. Now, there are four main models. You did good and do these in Algebra 1, so we're just going to review them. Just exponential growth without this word compound in it. So if it's just plain, this grows at a rate of 3%, you're going to use this formula. Looks like that. We'll talk about what the pieces mean. Now, if it says the word compounded monthly, quarterly interest, this is all these savings accounts, okay? Then you're going to use kind of the bigger formula. And we'll talk about again what these pieces mean. And yes, that's n times t as the exponent there. Let's look at exponential growth, but it's compounded continuously. Now, when you see this word continuously, you're going to use this little letter E in your calculator, okay? It's basically what it is to economics as pi is to geometry. And you could see down at the bottom of your paper, I give the approximate, and I'll show you where that is in the calculator too. But this will be the formula for that. So you can see the R and the T are the exponents there with the base of E. And then last but not least, exponential decay, but again, no word of compound. If it says one of these compounds, okay, then you would use this long. So that would just be there. So instead of 1 plus, which is growth, it's 1 minus. Now let's talk about what these pieces of all the formulas are. You can see the same variables are used in each of the model. So A is the amount or quantity after T amount of years, okay? So how much is in your account or how much is it worth? That's what A stands for, okay? Almost like the total at the end of time. P is the principal, or it's always the initial amount. How much do you initially deposit? How much was the car worth? How much was the ring worth? Initially, the starting point is always the P, and that always goes in front here, as you can see. R, okay, is the rate of percentage, okay? Also, the rate of interest. So it'll say, at 3% you buy this house, or at 5%. Here's the one thing to remember. You need to change the percent to a decimal, okay, which means move decimal 2 places left, okay? You got to move the decimal 2 places to the left. T in all the formulas is time in years. Now this one's a little trickier. This one goes with this compounded, okay? So these two go together. This variable n in this longer formula stands for how many times that the money is compounded. So how many times the money is compounded in a year. What that basically means is they're going to go back and reevaluate your account and then reassess the interest off what's now in your account. It's kind of strange. It's one of these money market or very growing bank accounts. So for instance, if it says, and here's your context clue, so if it says compounded monthly, then n is going to equal 12 because monthly would be 12 times in a year that they go back once a month and look over your account. If they say semi-annually, right? N would be 2. If they say quarterly, N would be 4 because there's 4 quarters, that kind of thing. Biannually would also be 2, sometimes annual. So it just depends, okay? Usually the two popular are monthly and quarterly, but that's what your N would be. So then last but not least, I did put this here so you could see. This again, you only use if it has the word continuously in the problem. And let's look at our calculator for where that is. If you notice here, if you hit second and then division, you're going to see this little E. This E is similar to the pi key, where it's going to be a continuous number, okay? And they use this anytime they're talking about usually growth or decay that happens very continuously. Like population problems tend to use this a lot, since growth is very continuous for populations, okay? So basically, pause this video now and take a look at these problems and see if you can pick the correct formula that would go with it and then evaluate and try to answer the questions. You will not have to memorize these 4, okay? You will be giving them for quizzes and assessments and such, but you need to practice what piece goes where. Make sure again you remember R being the percentage rate, change to a decimal. P is the initial amount. T is time in years. N is how many times it's compounded. So you want to try to stick out and see if you can figure those out. So take about 15 minutes or so and see if you can answer these. Pick the formula at least that you think would go with it. Pause the video now, and then we'll be going over the answers. Okay, so let's look over these answers here, guys. Hopefully you're able to try. You know, again, you have seen these back from Algebra 1. It's just a matter of refreshing your memory. So let's take a look at number 1. A diamond ring was purchased 20 years ago for $500. The value of the ring increases by 8%, so make sure you underline keywords. So initially was $500. I already know that's going to be my P. There's my R, because it's the percentage. Write the exponential function that represents the value of the ring for T number of years, and what would the value of the ring be today? So then, well, it doesn't say the word compound anywhere, and it just says increases by 1%. That is just exponential growth. So I am just going to use the very first formula, which looks like this. Now, our next step, okay, is to put in the numbers and then use our calculator. So here, the initial value of the ring 20 years ago was 500. Then our R is 8%, but you want to change that to a decimal, so that is 0.08. So this right here, and let's add the 1 plus the 8. This would actually just be the exponential function or the model for this problem. Then you want to use the model to answer this question. It says, what is the value of the ring today? So it's saying 20 years ago. So I want to know 20 years since it was worth 500. So I'm going to plug or substitute 20 in for T as the exponent. So I got the ring is now $2,330 and about 48 cents. And that's all there is to it, guys. So let's take a look at number 2 now. It says your sweet grandma gave you $1,000, and since you're so smart, you decided to deposit that into an investment account that pays 4% annual interest. Write the exponential model, then find the total in your account after 5 years. If it's compounded, here's your key word, compounded based on the following frequencies. So if it's compounded annually, that's just once. Okay? That means n's going to equal 1. And I know I'm using the really big formula because of the word compound. So that formula would be formula number 2, guys. Okay? Exponential growth with compound. So let's take a look here. So if I want to see, okay, our initial amount is 1,000. So P is 1,000. And then it's 1 plus, now your R, remember, needs to be as a decimal. So that's really 0.04. N is how many times it's compounded, which is 1. And then it says N times T, so 1 times 5 years, because we hold it in 5 years. Now be very careful how you put this into your calculator. Some people can write the formula, but then when it comes to putting it in, they do some little errors. So be very careful about how you put it into the calculator. Let's see, if we do this, 1,000, 1 plus 0.04 divided by 1, to the 1 times 5 is 5. Oh, don't use division, to the 5th power. And I got $1,216.65 is how much you would have at the end of 5 years. So you can see the actual interest is about $216. That's that almost money that the bank's going to pay you for banking with them. But again, the thing with these accounts is you usually can't touch them over 5 the whole time. Let's try the second one, quarterly. N is going to equal 4. So everything else is going to be the same, except instead of a 1 and a 1 here, we're going to substitute a 4 into the problem. So everything else was the same, because we're still using the same interest. So let's see. I'm going to put it in the calculator. Instead, a little bit more. Guess that would be up to you if you think it's worth it. It's about $4 more of interest that the bank would give you. Now the continuously part, right away, that's going to be using the E formula. Okay, so we're going to use that E key in our calculator to do this one. So it's still going to be, okay, total amount equals, so this again is at the amount at the end of the years. Principal, which is the initial amount, E to the R, which is 0.04, times T, which we know is 5 years that we're looking at. We're comparing accounts over 5 years. So now when you type that in your calculator, 1,000, hit the second division, okay, caret symbol, and then I'm going to do 0.04 times 5. Personally, especially if you have the TI-83 calculators, make sure that you put your exponent in parentheses. And then that got me $1,221.40. So you can see they're all pretty close together. I guess it depends. I mean, I would pick the account that goes continuously because it does give a little bit more money, but it's not too bad. So that's just a good practice of each one of those. You don't have to memorize the formula, but you need to be able to apply the pieces to it. Last but not least, let's take a look here where I give you kind of an application problem more as well. It says the number of endangered species, S in the world, can be modeled by the function, okay, S of t equals 250p. So you can right away, you could see, guys, when you have the E here, it's going to be continuous. So what type of growth does it represent? It's a continuous growth. And that's because of the E in the problem. Okay, that's because of the E in the problem. Anytime you see the E, it grows continuously. And usually population like this, endangered species, is under that category. What is the growth rate? That is the R. So you could see the growth rate is 0.07 because that would be where it's located in this formula. 0.07, which is the same thing as saying, if you move the decimal 2 to the right, 7%. Okay, so then let's take a look here. How many species are going to be in 1950? The number of species in 1950. Well, the reason why I'm asking this is to kind of get you used to the formula is this starts, okay, at 1950. T is years after. So 1951, T would be 1. 1952, T would be 2. So the initial amount at 1950 is already in our problem. It's 250. That is your p-value in this formula. P for all the formulas has always been the initial amount. You could also substitute 0 in for t, and you're going to notice you're still going to get 250. Okay, because that's the initial amount. So being able to read the problem. So now what you're going to be doing, okay, and you get a chance to start it in class, is a little review, okay? On Friday, we're going to do a review of all the 3 things we've been doing so far with the calculator. So the first part is all this compound interest, exponential from today, okay? Use your notes for the formulas for these. The second part is explicit formulas, okay, and series formula, geometric, arithmetic. And the third part, okay, without a calculator, is again, what are the shifts of the graph, that kind of thing, is it growth or decay? Come next week, on Tuesday, sorry, it should say Tuesday, 8A, okay, you will be having 3 mini quizzes on these topics. So Friday is going to be a review day. We're going to go over this. I'll have all the answers. We're going to review all day Friday. Tuesday, when you guys come in, you're going to have 3 mini quizzes that will go in as separate grades on each topic. So take these 3 topics seriously. Use your notes for the formulas, and when it comes to the quiz, you'll be given the formulas, okay? Except the one arithmetic series formula. Everything else you'll be given.